This is a quick guide to getting you set up in your GitLab account at the University of Waterloo. You have one automatically. If you've never used it before, then the first time you sign in, it will be activated for you. Now, all of our exercises are designed and set up to be run using the ECE Ubuntu servers, and although you can test and develop the code on your own laptop, core staff will only be able to support you running on ECE Ubuntu. So if you're having some problem on your laptop, there's missing libraries, or something doesn't compile or anything like that, the first thing that we would tell you is try using it on the ECE servers. Now, preferably in advance of the first actual assignment or exercise for the term, you want to do the following things, and the first thing is set up your GitLab account. GitLab is web-based software for managing source control repositories, and the university offers this as a service at git.uwaterloo.ca. And once you navigate there, you will be presented with this login screen where you log in with your usual university credentials. So we'll log in. If you have not logged in before and you haven't set up your account, then you definitely need to do that. Most importantly is you need to configure your SSH keys. So click on the avatar at the top and click on Settings, and then select SSH keys in the menu. On this page, you will be given instructions here at the top about how to add your SSH key. If you already have an existing one, then you can follow this link here to the existing one. If not, then you can follow the link here to generate one. And once you've generated it, you paste it into the box here, and then you can add it to your account here using add key. To test whether you are able to successfully log in to the correct server, there's two ways to go about it. The first way is if you have your VPN on. Most of the ECE servers are not reachable from outside the firewall, so you get inside the firewall using the VPN. If, however, you don't want to do that, or you can't for some reason, then you can connect to the ECE term server, and from there to the server of your choice. So I will SSH my user ID at eceterm.uwaterloo.ca. This will prompt me for my password. This is, again, your standard single sign-on credentials. And from here, you will then SSH to ECE Ubuntu. Again, you will need to enter your password. And then you are on the correct server. You'll notice at the bottom where it says the host name here, it's ECE Tesla 0. There are a number of different ECE servers, and if you just SSH to ECE Ubuntu, it connects you to any one of them, and they should all be equally valid for completing the assignments as required. That is, of course, the workflow for if you are using Linux or Mac OS. If you are using Windows 10, my recommendation is that you install the Windows Subsystem for Linux, or the WSL, and the instructions are linked in the exercises setup guide. It takes you to a page like this, where you just specify the distribution of your choice. We recommend Ubuntu for this purpose, and that allows you to very easily launch a Linux terminal and just connect using all of the standard commands. You can also use a third-party client such as PuTTY or MOBA Xterm or something like that. For space reasons and time reasons, we're not going to go into the full details of how to configure those. They don't come with my recommendation, but they are a valid option if you wanted to do that. For transferring files, whether it's on Mac, Linux, or some other operating system, you can use SFTP. This is SSH File Transfer Protocol or Secure File Transfer Protocol. But if you do all the exercises just simply on ECE Ubuntu, then you don't have to move files. You can also map your drive, and your drive being the files that are stored on the Unix systems at the university, so you can access them like it's a standard folder. That is something that comes with my recommendation. The last thing to do in terms of getting set up is to learn a little bit about Git if you don't know already. Linked here is a Git
book, which gives you some information about what you need to actually use it. Some of the things are much more advanced than we want to talk about. We will probably not talk about branches or anything like that because it's not really necessary for actually doing the assignments that you need to do. However, it does give you a nice overview of what Git is about and how to do things. And if you have questions about, how do I record changes, or how do I undo something, or anything like that, then this reference is quite handy. If all of that seems like too much reading to you, you should read it, but if it seems like too much reading to you, then I'll give you the very quick start guide for what you actually need to do. So first thing is you need to set up your Git on the ECE server. So we're going to do git config global user.name, and then of course your name instead of mine. Quotation marks are important. And your email, once again, yours instead of mine. And then you've got that set up. Now, to actually work with a repository, you need to clone it. So to actually clone it, if you look in GitLab at the repository that you want to clone, then you select here at the top right the clone button, and you want clone with SSH. And you can click on copy URL, which will then copy the URL that you need to the clipboard. Now, you should make sure that you've actually copied the one from your repository and not the one from the course instructor. Otherwise, you won't be able to submit your changes. And you can verify that by git clone and then paste the URL that you are looking for. You should, of course, see your own name here in this because it should be in your personal space. This example shows here in the space ECE 252 because I'm just using it as an example. And you will click on clone. Now, if you have set a password for your SSH key, you'll have to enter it. If you did not, then this step will not appear, and that's not bad. It's just normal. If this doesn't go well, it's probably a problem with setting up of your SSH key. If it needs to be checked, then you should fix that at this point. Otherwise, you can't successfully clone it. If, however, you do get this output that shows here, it means you have successfully cloned that code. And so then we will enter into that repository. And while we're here, you can see what the files are. There are a number of different files, and you're ready to start working on it. So open the code in your editor and get going. Now, when you have made some changes, I'll just add an irrelevant comment here. So there are some changes that we can see. You can see what changes have been made with both git status and git diff. Git status tells you what files have been changed. Git diff shows you the actual changes that have occurred in those files. When you are ready to submit your changes, you can use git add and then the name of the file that you have changed such that it is added to the next commit. Commit is a package of changes that you are going to put together. And when you're ready, you use git commit. And git commit opens up your editor once again, and it asks you to give a commit message as well as shows you what changes are being committed, as in what files are being changed. So you then, this is a meaningful commit message. And when you are done with your editor, your commit is finished. That's, however, just for now on your local machine in this local directory. If you actually want to submit those changes, then you use the command git push. And git push then transfers those changes in your commits to the GitLab server. You need to remember to do that because otherwise we don't see them as the course staff who are going to evaluate it. If you have modified anything since your last commit, that's not included when you git push. Only actual commits have been sent using git push, so make sure to do that. And the code that you have been provided here comes with a make file. The make file is used to tell the make command what to do, how to build the code, so you don't have to actually invoke the compiler directly. All you do is type make, and you will see some output there where it actually then generates the commands that are needed to compile your code, and it generates an executable file. You will notice now, if we look at the contents of the directory, there is a new file here. This one is called arrow, and that is the executable file. If there are no errors. If there are errors, then you will see error output, and it will tell you what went wrong, so you need to fix that before you move on. If you see warnings, that doesn't prevent generation of the executable file, but you should look at them, and they might tell you something useful, so you should pay attention to them, and you should resolve them if you can. If you're having trouble with a particular error, then the internet, of course, will help you out with that. If you actually want to run the code, then you use the // prefix. This means you explicitly want to run the executable file in this directory, and that's what you do. So then you will see some output, and the output of this program is incomplete because the exercise in question is not finished, and you can kill its execution if you think it's stuck with the Control-C command. If your program takes arguments, then they follow on the same line, so arg1, arg2. If it takes input like that, some programs take argument like -t4, where -t has some meaning within that program, such as create 4 threads, and a second argument -i input file.txt. And that is how you would actually execute the program. And so when you are ready, you can edit your code, you can test it out after building it with make, and if you're happy with it, you commit and then push those changes, and that's the basic workflow for how you complete an exercise.